All right. Oh, shoot, I can hear myself a bit too well. Where does this come from? It's from here. All right. Okay. Not anymore. Right. All right. We're gonna do some math. Yeah. Yeah. For my enormous student job, I'm not in the greatest of math moods, but what needs to be done needs to be done. So sequences and series. Now I luckily remember nothing about it. So that's pretty straightforward. Other than that they exist. So let's go. 11.1. The sequence is an ordered list of numbers. Yada, yada, yada. Finite sequence, an infinite sequence. And sequence can be specified by an equation or rule. For example, finite sequence, yada, and infinite. Okay. So an is 2 or f or y is 2n, right? Fn is 2n, whatever you want to call it. While the domain of a sequence typically begins at 1, it can start at 0, right? In such cases, the domain consists of non-negative integers. Normally it's at 1. All right, I understand that. Okay, so write a rule. All right, so 11.1. The lighting is might be a bit shitty. Sequences in series. I have to do 15 pages of this. Well, I don't need to do it. Okay. So everything I can do, I will have to do really quickly because yeah. So 1, 1, 2, 2, 3, 5, 2.54, 4 point. Well, so okay, so y is x plus b, y is 3 over 2 times x. And then we should 10, so 30 over 2 is 15. Okay, 14 and a half. So that I did a great job there. Um, it is 1. It is 1 plus 1 is 1, no? And 2 is like, so 1.5 less. So it's 0, it's 0, it's minus and a half. Right, so it's 1.5, 3 over 2x minus 1.5. Okay, those are still easy, but later it becomes a bit harder. So explanation. Okay, so y is 3 over 2 times x minus a half. And then so how do they do? So these 1.5. Okay, so there's a constant thing which is 1.5. And then well, and minus 1. So this is I'm already a bit stuck. I can't imagine I'm going to 15 pages of this. Okay, B is yeah. So okay, A10 is the first one is easy. B is let me quickly plug in an energy source for my phone. B is so minus and a half. So at 0, it's 9.5. Y is minus 3 to x plus 9.5. And then A10 is minus 15 plus 9.5 is 5.5. Minus 5, yeah, minus 5. C squares. Okay, so A is n squared divided by 4, right? So n squared divided by 4, or x squared, yes, divided by 4. And then 10 is 100 divided by 4 is 25. So 10 is 25. Okay. D. Geometric sequences. All right. So difference is 1, 2, 4, 8. So 1, 2, 4, 8. That's 2. Write this down. Let's get another piece of paper just to scribble on, because it's somewhat. Okay, so 1, 2, 4, 8, 16. So this is 1, this is 2, this is 4, this is 8. 1, this is 2, and this is 4, etc. So if that happens, if you have like 1, 8, 27, 64, what happens here? So that's there. That's 19. 25, 30, 34, 37, 64. So this is 25 plus 38, 58, 60. 18, six, huh? Ah, my phone is ringing. Away? Yo, 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 yo. This is high school stuff. This is high school stuff. One moment. Ah, okay, okay. I see. Sorry. I'll put my phone back on. I'll put my phone back. 1 second. Uh, 1 second. This is supposed to be high school stuff. I mean, I find it really hard. But I'm supposed to tutor this tomorrow, and I'm like, yeah, it is a little bit hard, so to say. Sorry, I missed your welcome Q trials. I wasn't really paying attention to the chat yet. I was a bit like. Yeah, it's about series, and I'm really a bit puzzled. And mathematical induction. Is this uni now? This should be still. I can't. I mean, it is somewhat hard, isn't it? Yeah, everything times two times it's 16. Yeah. So that's two to the power of n minus one. Because at one it's two to the power of zero, and at two it's two to the power of one, right? So it's at one it's two to the power of zero. And at two it's two to the power of one, and at three it's two to the power of two, which is n minus one. Right. So at one is two to the power of zero, and at two it's to the power of one, and at three it's to the power of two, and these are all one less than, you know. So this one is, it's nice to have the answer in front of you, is the y is 2 to the power n minus 1. Let's call it a as they do. And then a10 is 2 to the power of 9, which is okay. Alternating sequences, so then there is a negative somewhere. So 1 minus a half, a fourth minus 8, 16. So it's everything gets halved. So it's minus half. So at 1, it's minus a half to the power of 0. And at 2, it's minus a half to the power of 1. Oh, so 1 to the power of 1. And it's the same idea, no? And then at 3, it's minus a half to the power of 2. So it's the same idea. Yeah, okay. So A is minus a half to the power of n minus 1, and then A10 is, so this is 9, right? So this is minus 1 over 512. Okay, that's correct. Triangular numbers. What's your union? No, man, this is welcome if you're still here, by the way. If not, this is like this is first. This is like, yeah, this is high school. Also, not even. Anyway, so I have to teach this basically, but I'm learning it myself right now. I don't think I ever did this. So yeah, regular numbers 1, 3, 6, 10, 15. What is the thing here? 15. So this is 2, 3, 4, 5. So this is a polynomial, right? Second grade polynomial with y is x. So here so it's an so a is so it's at 0 at 1. So you can, so at 1 it's 1, and then at 2 it's 3, and then 3 it's 6, right? So 3, 2, so it's 3, 1, so it's 0, it's 0. So oh, it's 1 plus 3 plus 4. It is 1, and then plus 2, and then plus 3, and then plus 4. So there are two ways to do this. So first of all, it is 1 plus 2 plus 3. Oh boy, this is going to be a disaster. So first of all, indeed, I'm not used to this. Let me have this. It's 1 plus 2 plus 3 until infinity. And then there is like, you could also do like a is, let's just y is ax squared plus b with o where will be it. Is that true, by the way? Three, two, oh no, and then oh, so a plus b plus c is 1. This one is really convoluted to do this way. It's much easier. Let's do it though. Then one is this. You also get c. C is 0. So a plus b is 1, and then there is 2, 3. So 4a plus 2b is 3. And then a is b minus b plus 1. And then 4 minus b plus 1 plus 2b is 3. Minus 4b plus 4 plus 2b is 3. And then minus 2b is minus 1. Does this work? And then b is a half. And a is also a half. I don't think this is correct at all. Oh, it's correct. And then, so therefore, a is 1.5 n squared plus a half n, which in turn is a is n squared plus n divided by 2. And then a10 is 100 plus what is 55. Huh? Oh, you got it. Yeah, how cheap. Finish it. N squared plus n. Your plus it. Divided by 2. Oh, A100. But they asked for A10, right? So it's 55. Okay, so you can also do it that way. I don't really understand. I mean, yeah, it's a bit more convoluted. But you can do it that way. Okay, page number 2 out of 50. Okay, so this is page 1, right? Page 1. All right, guys. So I got some delivery like downstairs. So I'm gonna I'm gonna pick it up now, basically, and have a few bites while I'm suffering through this. Basically. One second, I'll be back in like 2 or 3 minutes. All right, I'm back, guys. Let's go on with with the suffering. So I got some stuff, as you can see. It's Vietnamese. Vietnamese. It's like a 炒牛肉炒饭. It's a beef fried rice. And we got some soup actually. I have to clean my bowl though. So I'm very good at pouring soup. I can tell you that with the normal amount of sarcasm, so to say. Because I'm really bad at it. But I'll have that in a bit later. So we're gonna suffer through everything. Okay, so example one, the first five terms are easy. You just do 1 through 3, 1, 2, 3, 4, 5, right? It's just an exercise. I don't know what exactly. I'm sure it's good. But it looks good, guys. I'm not sure if you can see it. You can't. Oh, you can. Mm, it looks solid. It's slightly different from the. I mean, it's fried rice, of course. Hmm. Okay, first five terms of another sequence. Okay, I believe that. Okay, writing rules for sequences. Now this one you could just barely do basically. Describe the pattern. -8, -8. So this is a minus x to the power of 3 basically, right? Yeah. Okay, so that one is simple. Then the second one, the right rule for the nth term of the sequence. Yeah, okay. Right. So the second one, we have to do some, we have to figure out some stuff because I couldn't really do it. I was briefly looking at this before the stream. Now I was like, oh, how do you do this? So it's pretty simple to see that it's a polynomial with how do you call it? Right? Grade 2 or whatever it's called, to the power of 2. So as a squared plus bx plus c. Now, of course, you can then just do like 1, 0. I mean, you can just do that. At 1, it's 0. And in this case, because the difference is 4, so it's like 6, 4, 2, and it's 0. So 0 is 0 and 1 is 0. So, and then you can just put into numbers, I guess. I don't really know a better way to do it. Dude, this thing won't open. H2. So example 1. So A is minus n to the power 3. But you have to, they're all negative, no? So you have to write it down like this. And B, so for B we have 0, 2, 6, 12. So we have 1, 0, 2, 2, 3, 6, and we have 0, 0. So if we just do C, then we get C is 0, A plus B is 0, and 4A plus 2B is 2. So A is minus B. So minus 4B plus 2B is 2. So B is minus 1. And A is 1. So Y is x squared minus x. So that means that A is n squared minus n. All right, that works. I see what I did wrong. When was it? I can't exactly remember. In April 2024 or something. I was struggling with this a little bit, but I see what the problem is. Okay. I was also really ill and somewhat unsober. Self-assessment. Describe the pattern. Write an extreme. Right. Okay. Self-assessment. Okay. Describe the pattern. So 1 is 1 minus 2 4 and minus 8. Good morning. So this one has a minus sign. So this one is a So this is one way of looking at it. However, it will be to the second degree, so it's not that. So that's 1, 1. 2 minus 2. 4, 3, 4, 4, So this is minus 2 also. This is minus 2 to the power of 0. This is minus 2 to the power of 1. It's minus 2 to the power of 2. It's minus 2 to the power of 3. So 1, 0, 2, 1, 3, 2, 4, 3. So this is minus 2. Minus 2 to the power of n minus 1. Oh, you have to use? Okay, fair enough. You have to use it. Isn't there a slightly prettier way of solving this? 2, 5, 10, 17. So this is 3, 5, 7. So this is just, you can just write as a simple polynomial. And so we have 1, 2, 2, 5, and 0. So the difference should be 1 here. So 0, 1. So 0 is 1. So if y is ax squared plus bx plus 1, then we have a plus b is plus 1 is 2. So that is a plus b is 1. And then we have 4a plus 2b plus 1 is 5, which is 4a plus 2b is 4, which is, so a plus b is 1, and 2a plus b is 2. So b is minus a plus 1. So 2a, so a minus 1 is 2, a is 3, b is minus 2. So almost didn't cut. Yeah, it is wrong this time. And this is also n squared plus 1. It's pretty easy to see. Well, let's quickly do it the official way. It's plus 1. Hang on now. So let's do this again. So a plus b plus 1 is 2. So a plus b is 1. And 4a plus 2b is plus 1 is 5. What did I do? So 2a plus b is 2. So I did something really dumb. It's plus 2. So a minus 2a plus 2 is 1. Minus a is minus 1. A is 1. A is 1. And b is 0. Then b is 0. And then it's correct. Y is x squared plus 1. So, and a is n squared plus 1. All right. I see what I did wrong there. I see what I did wrong. So example 3. So 149, 149, 16, 25, right? So 1 is 1, 2 is 4. So a is actually just n squared, right? I'm doing something seriously wrong. That's obvious. No, but it is n squared. This is where. An equilateral triangle. Aha. It's a triangle. So it's 1. Okay, so it's 1, 3. 6, 10, 15. So that's indeed 1, and then 1 plus 2, and then 1 plus 2 plus 3. One, 3, 2, 3. This topic is not exactly my best topic. But let's battle on. I'm really a bit confused about this explanation. Again, so delete A, right? All right. You just have to be a bit neater. All right. Okay, sigma is your, or I don't really know. So sigma, whatever. So let's check the example. So if you have 1 squared plus 2 squared plus 3 squared plus 4 squared, etc., etc. Ah, okay, so you write a sigma, then 10, then I is 1, and then I squared. Okay, yeah, for infinite series, right? Sense? Any other letter? All right, all right. I would really not choose I because I find it miserable. I'll choose another letter. All right. Let's do example 4. Okay, write a whole bunch of stuff using summary notation. So, okay, 1 plus 2 plus 3 plus 4, 5, and then plus 100. Okay, so you write a big sigma. And the final one is 100. That's easiest. And I will use k because it's just. And then below you do the the initial value. Okay? And then lower limit. All right, I finished my my fried rice. It was pretty good. I mean, it's fried rice. I shouldn't eat fried rice because I have to lose a whole lot of kilo. Hey, let's not make it myself too hard. Rome wasn't built in one day either. You know, not that I'm building Rome. Don't get me wrong. You get the. So they give an example, by the way, which is so they give like this one, okay, to infinity, like this one, to infinity. And this is a half to the power of I'll do k, okay? K minus 1. Here they say k is 1. So the initial number is 1. So 1 times 1 minus 1 is 0. Well, 1 half to the power of 0 indeed is 1. And then 1, then 2 is a half. Right. Right, so this is 1 plus a half plus quarter, right? Plus 1/8. So up to infinity. Okay, you got that. That. And then below there's k is 1. No, hang on. Yeah, k is 1. Okay. Then b is 2 to the power 1 plus 2 to the power 2 plus 2 to the power 3 plus 2 to the power 4 plus up to plus blah 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 up to 2 to the power 50. So then you write a big sigma, isn't it? Sigma, and then you write a 50 on top. 1122. So and then the k is 1, right? And then k is, and then here you write a 2 to the power of k. Okay. So 1 for 1 it's 1, for 2 it's 2, for 3 it's 3. Okay, this one is a little bit weird. So 67 to the power of 2, 68 to the power of 2, 69 to the power of 2, plus yada yada yada, plus 2026 to the power of 2. So then we do the big sigma again, right? So 2026. So it's just k to the power of 2, and it starts with, okay, this is still understandable. So here it's 67. Right? And it's just a thing. So D is 25. This one is a bit weird. Plus 50 plus 75 plus plus 250. So we write down a big sigma. And then 250. And then it's 250. Okay. So this surely is 2k or 25. So 2k, okay. I is 1. 25 times 1. So 25 times A and A is what? And a half is 10. Let's just go on. 2. So E is 1 plus 3.5. Okay, so 1 plus 3 plus 7 plus 9 plus 30. And then it's 7. So okay, so we get a big sigma, we get infinity sign, and it starts with 1, and it's 2k. Minus 1. Fair enough, because it is 2k. Okay, and then F. I should be a little, okay, so let's see if I can do this by myself. Okay, so this is a big sigma, and it goes to up to. Okay, so the first one is easy. So it's k to the power of minus a third, of a third, not minus a third. Or, no, it's a third to the power of k. And then, but below there, what is it? Is it a 1 or is it a third? Well, it's 1, no? Times 1, yeah, okay. The third, right, the third, okay. Okay, we still got this one. So, okay, this one looks a bit harder. Plus 2 third plus 3 4 plus 4 5 plus yada yada yada, right? So we get the big sigma going, and then we do a bit of this, right? Okay, up to there it's simple. So this is k divided by k plus 1. It starts with a 1. And let's see. Ah, yeah. Okay, I might be getting the hang of it a little. It's just the value below, because this one is a bit weird. And this one. But we'll figure it out at some point. What on earth exactly we're supposed to. So minus 2 plus 4 minus 8 plus 16 minus 32. Okay, up to infinity, right? Okay, so we this. So this is a minus 1. So this for 1 it's minus 2, for 2 it's 4, isn't it? So these are like minus 16, 32. So these are like powers of 2. So this is minus 2, minus 2 to the power of 1, then 2, and then 3. So it's just minus 2 to the power of k, starting with 1. Yeah, I think I'm getting. Okay, write a series using summation notation. So, uh, so this is the first one. So self-assessment 1, 2, 3, right? So okay, so self-assessment. The first one is Big Sigma. I am running a bit out of steam, I have to say. I'm gonna try to do 1 more hour, and then you know take it from there basically. Because I need to do a lot more. For if I can at least can get at least halfway, I'm pretty sure I can. Normally should be able to finish it tomorrow. Does it get much harder than this? Here there are no answers anymore. So no, this gets a lot harder. Really up to 15. Holy shit, man. This gets pretty tough. Oh, this is already 18, so don't need to look that far up to here. Okay, you do this, finding some geometric series. Oh, so we're gonna do this Gauss thing. Geometric. Then where the sequence is geometric, it's really easy. Uh, this one probably is this one. This one. This is times 6, no? Times 3, times 4, times 5, times 6. Well, so this one also is it? So this is 2 times 1. This is 2 times 1 plus 2. This is 2 times 1 plus 2 plus 3. This is 2 plus. Anyway, I think All right, so it's 100. So this is 1. And k is just 5. So here we still get answers, right? 5. Then 2, a half, plus 4, 5, plus 9, 3, plus 16, 17. 1 4 9 16. Okay, so big sigma, and this goes on for. So this is infinity. So this is k squared divided by k squared plus 1. And it starts at 1. Okay, that's correct. And then 3, 636. Okay, 6 plus 36 plus 2, 16 plus 12 minus 6. So that's times 6, that's times 6, and that's times 6. Okay, so and this goes on to infinity, right? Okay. So then you have a sigma. So that's a thingy here. And then it's 6k and it's 1. Right? No. Hang on. This I don't know. So 6 times 6, 6 times 6, 6 times 6 times 6. So it's k to the power. How do you write this? So it's 6 to the power of k. 6. Okay. Critical thinking. Use the diagram to determine the sum of the series. Explain your reason. Critical thinking. All right, critical thinking. Use the diagram to determine the sum of the series. Explain your reason. So it's 1, 3, 5, 7, 9. The sum of the series, right? Sum of the series. So what is the series? What is the 7, 9? What's 2? Why is 99 there? 1 plus 3 plus 5 plus 7 plus 9. So for 1 it's 1, for 2 it's 3, for like. So this is 2n minus 1, right? So a is 2n minus 1. And then what is the point? It's 100. This goes to infinity, you know, that's the point. It never writes down up to 1. So this is really, there is really a problem with this question. So let's not bother with it. So page 5. And find the sum of the following series. All right. So that's like the sum of the following series. So this is a big sigma, right? It's 5, it's 8i, and it's k, right? K is space 1, right? Okay, so k5. So 1, so it's 8. Okay, so the sum, right? So it's 8 plus 16 plus 24 plus, so 5, right? So 32 plus 40, right? Which probably equals 120. What's more interesting is that it is 40. It's how you get there, no? What's the enormous trick? Okay, I mean, it's 8 plus 5 times 8 minus 5. And it's probably not a trick, it's just coincidence. All right, let's figure it out later. So 3 plus a squared. So this is 8, and this is 1, or 4. All right, so this is like, okay, so this is like, I think I understand. And that turns out to be 205. Yeah, found it. Yeah. 15 plus the whole thing. Right. Let's see what C is. So 4 times, and then n to the power of 3, and it starts with a linear 0. Okay, so this is 4, right? So this is 0 to the power of 3, 1 to the power of 3, 2 to the power of 3, 3 to the power of 3, and 4 to the power of 3. Right? So which is 1 plus 8 is 9, plus 27 is 36, plus 64 is 100. And then sigma, it's 7, k is 3, k squared minus 1. K squared minus 1, k is 3. So it's 3 squared minus 1 plus, right? 4 squared. Okay, 4 squared minus 1. And this plus 5 squared minus 1 plus 6 squared minus 1 plus 7 squared minus 1, which is so 9. So 9 plus 16 plus 25 plus 36 plus 49, and then minus 7, which turns out to be minus 5, and then it turns out to be, all right? E, okay, E is pretty simple. F sigma 6 n is 4 n plus 1. 6 n is 4 en n gedeeld door n plus 1. Dus you begin by 4, right? Okay, up to 6 now. So it's 4 divided by 7, which is 24 plus which is 25, 24 is 49, over 5 over 7, which is it really becomes a big number. I peaked in there, it does. So it's 210, and then 280 plus 180, so it becomes 460, 210, 4621. Oh, I didn't know. Okay. Yeah, 200, yeah. Oh, I made a mistake here. 24 is 3. I wrote it down. Don't do that. Okay, so this is like 25 if you 3 is 130 divided by 15 is 523. Formulas for special series. Sum of squares. Sum of cubes. Right. Okay. Sum of the first n positive integers 1 plus 2 plus 3 plus blah 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 1 plus 2 plus 3 plus yada 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 plus n is sigma, right? Okay, so this is n, this is 1, and this is, so k is 1, this is 1, and then k is okay, right? And this is the same as, oh, we've seen this one. Y is 1. Oh, this is the sum. Oh, okay. So it's 1, 3, 6. Right. 1, 3, 6. And then the sum of squares. So 1 squared plus 2 squared plus 3 squared plus up to n squared is sigma, and then n, right? And then n squared, okay, and then n is 1. And then it is, the sum is n plus 1. Hey, this looks very familiar, doesn't it? 2n plus 1, and then divided by 6 or something. No, it's really. Okay, and the sum of cubes. Yeah, it looks familiar, doesn't it? I understand what happened. I understand what happened. So it is true. I mean, now they're obviously with these things, they're going a bit over the top about many things. I'm pretty sure, but I understand what happened. I understand what happened. I could have made my life a lot easier, but I was so pissed off that I was like, "You go fuck yourself." While they were busy doing all kinds of research and all kinds of nonsense, I was just extremely pissed off. Did you read what happened? Right? I told you as well. That went a bit over the top, so to say. The, the, all right, I'll do the rest tomorrow. So, is this really like? Is this really high school stuff? I have so many big doubts about it. Normally they go a bit like, is this really high school stuff? Like, yeah, I don't really. Yeah. My life is a bit of a strange affair.
Yeah, I mean, I don't know, man. I mean, you want it to be real, well, it'd be real then, but then it's not going to be overly good, so to say. Anyway, I'm not going to. So, how far am I in? So you have to do these things. Page 15, right? The sum of cubes, so 1 to the third plus 2 to the third plus 3 to the third plus etc. up to n to the third is sigma n, and then k to the third, and then k is 1, right? And then the sum is n plus 1 divided by 2. The whole thing. Okay, that one. So squares is like that, okay? And then cubes is like that. So you would wonder if it's to the power of 4, what's it then? So n plus 1 divided by 2. 2n plus 1. Ah, okay. So it's 2n plus 1, n plus 1, and then 2n plus 1. 2n plus 1 is 6, so it's uh, 1/3 n plus 6. N squared plus n plus 4/3 n plus n plus 1. Oops. So it's n squared plus n is divided by 6. Times n squared. Anyway, for now, let's see. We have more time. Number 6. Find the sum of the following series. So it's like n plus 1 minus 2. So 20, so 20 times 21 divided by 2. So it's n plus 1 is per the other. Probably a sigma resolution. Sigma to let's see be a constant. The horizontal. All right, so where was I? It's 8:11. Normally I'd stop now and go drink it. I mean, not without a reason, right? Example 6. So A is, I won't be able to finish this tomorrow. It's too much new stuff for me. So 20K and K is 1. Okay. And then so the sum, right? So the sum would be like the first one. So it's n plus 1 divided by 2. So that's 20 plus 21 divided by 2. And times, which is B is 100K squared and K is 1. So this is the enormous, so the sum is 100 times 101 divided by 2 to the power, and then to the power 2. So that's 50 times 101. So that's 5050 squared, which is, oh, divided by 6. Okay. Divided by 6, which is, this becomes a beautiful number. Yeah. 100. Oh, 2n plus 1. I just did it completely. This is 200. Okay. And then divided by 6. 180 is 31, so you can't divide it nicely by 6. 21. What do you mean? It's 3.5. So it's 30. 180, 30, 21. So 33 and a half. So 100 times 33 and a half. And then the whole thing cube is 3,350. I mean, what is it? You can also do that. You see? 10 I3 I1. 10 I1. Then we have another beautiful formula. Oh, I did complete and then divided by 6. Divided by 6. Okay, so I did the wrong formula. That's genius. Even more genius, so to say. Times 11 divided by 2. It's 55 squared. Right, okay. Okay. Properties of signal notation. All right, so Properties of sigma notation. So one is like a sigma, and this is NC, and I is 1, NC I is 1 is n times C. Okay, let C be a constant. What is 3? Ik heb er geen zak van. In de mannenkamer. Ik snap er de ballen in. Properties of sigma notation. En maar deze C is C times. So it's n times C. Yeah. Right, it's pretty simple. You just do the same series and then divide it by 2. That's a pretty nifty trick. It's not even hard. Okay, once you know it, right? Once you see it. Before that, of course, it's not so obvious. But once you know it, it's pretty simple. Yeah, so it makes a lot of sense. You just take the reverse one, you add everything up, and then etc. Right? And then divide it by 2. Okay, I'm kind of halfway now. I mean, is I'm gonna do it tomorrow. Okay, I won't be getting completely healthy today. It will be very soon, maybe tomorrow. Yeah, I got to, but it won't be today. I'm suffering really. All right, it was 2 hours of math. I'm supposed to do this up to page 15. I'm not gonna make it. I'm gonna try. Yeah, so you can write everything as a series. I wish they had taught me that in high school. It would have. It's not really important to me. For a long time. Yeah, Ash is gonna. Ash, the engine is empty. It's already 8 o'clock. I mean, to be honest with you, 8:30 p.m. I woke up at 3 and couldn't really sleep anymore. Then I did all kinds of things. I had to go to the doctor. I'm back to the city. I'm back here. 20 something kilometers. I slept like maybe 10 minutes in the afternoon. Blah, 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 blah. Anyway, I'm talking too long. But I'm kind of. Diesel is up. So to say, if you understand what I mean. So everyone have a good day. I hope you enjoyed some math. Today I wasn't really. I mean, I'm doing all right. I mean, there have been a few streams where I was more into. Today, I'm not completely that. But that's okay. The topic itself is interesting. It's not that. Like geometry, I'm always a bit like. I mean, it's a bit more interesting. trigonometry.
What is this? This is page 15. Yeah, you take the reverse one and you divide it by 2. The second one is take 2n plus 1 is 6. 2n plus 1 n plus 1 plus 3 n plus 1. If you do this, okay? Yeah. So if you have like n plus 1 and 2, then it's nothing. It's squared. It's like n squared is n squared plus n squared. Ah, this was this pattern. But why is this 6 and why is this 2? And why is this 4? Anyway, I think it will be fine tomorrow. Let's hope that the tutoring goes well. All right, as she's done for the day, you will be back tomorrow morning, guys. You will be back tomorrow morning with the same stuff before he has to go. All right, have a good day, everyone.